Guys, good morning. So what we're going to be doing today is we're going to be working on some sex-linked inherited Punnett squares. All right, so I have two practice problems here that I'm going to be working out, and I'll also go ahead and write down a cheat sheet. That way when I post this, you can use this for your quiz. But for right now, I'm going to show you how to interpret problems for sex-linked inheritance and how to set up a Punnett square, so that way you know how to work them for your quiz. So like I said, I have two examples here. So my first example is on a syndrome called anhydrotic ectodermal dysplasia. So this is an X-linked recessive condition. Okay, so that means this is a recessive trait. The symptoms for anhydrotic ectodermal dysplasia include the lack of sweat glands, no teeth, and underdeveloped fingernails. So we're going to say that X big A represents the presence of sweat glands and teeth. Okay, so that's normal. Okay, so normal equals X big A. So X little a represents anhydrotic ectodermal dysplasia. All right, because this is a recessive disease. So it says, what is the phenotype of a woman who is X big A, X little a? Okay, so she's X big A, X little a. Remember, sex-linked travels on the X. You're not going to find it on the Y. So it asks, what is the phenotype? Is she normal or does she have the disease? So because this is a recessive condition, she is normal. Okay, but is the woman above a carrier of the gene? Okay, so remember, a carrier means that she's heterozygous. Okay, so she's heterozygous. So is she heterozygous? The answer is yes. All right. So if you have a man who's X big AY, what is his phenotype? Is he normal or does he have the disease? Well, in this case, because he's X big A, he's going to be normal. Okay, and remember, sex-linked inheritance travels on the X, not on the Y. So the Y is not going to have a letter above it. So the question asks, what are the chances of two people described in A and B? Okay, so A, X big A, X little a, and B, okay, so I think it should say C, X big A, Y, having an anhydrotic ectodermal dysplasia male child. Okay, we're just looking for the boys. So I have a little Punnett square here. I'm going to go ahead and write everything in. So my mother was X big A, X little a. Okay, so you notice my A travels with my X. It's on my X chromosome. So my father was X big A, Y. So now I'm going to do the same thing as I do before. Okay, my Punnett squares on the top go down. The ones over here come over. Okay, so my first box, it's a girl and she's X big A, X big A. My second box is also a girl, X big A, X little a. Third box is a boy, X big A, Y. Okay, remember there's no A on the Y. And then my last box, X little a, Y. So the question asks the chances of these people having an anhydrotic ectodermal dysplasia male child. Okay, so if I look at my Punnett squares, okay, so 50% of them are boys, but of those boys, one of them has the possibility of having that syndrome. So of my Punnett square, 25% would be the chance for having an anhydrotic ectodermal dysplasia male child. Okay, because this is asking for the whole Punnett square. So that's my first example. My second example has to do with rickets. So rickets in this case is an X-linked dominant condition. So this is different from the last one. This one's a dominant condition because of the lack of vitamin D. So the symptoms of rickets are swelling in the joints and the bend of the long bows, which causes bow legs. So in this case, X big R represents rickets because this is a dominant disease. If you have that dominant allele, you're going to have rickets. X little r in this case is non-rickets, which is normal. So if you have a man with rickets and he has children with a woman who does not have rickets, what are the chances that they will have rickets that are males? So they don't give us the genotype. We need to figure this out. So we know men are XY. So if this man has rickets, and rickets is a dominant disorder, we know he's X big R Y. Okay, so I'm going to go ahead and put this right here. Man is X big R Y. The woman does not have rickets. Because she does not have rickets and being normal is recessive, we can figure out her genotype too. So she's XX. We just need to figure out what those R's are. Because she does not have rickets, she's normal. So both of her X's have to be X little r's. Okay, so she's X little r, X little r. So we have a Punnett square here. We can go ahead and set this up. I'm going to put the woman on top, X big R, or X little r because she's normal. The man does have rickets, so he's going to be X big R Y. Now I'm going to do the same thing as I did in my last Punnett square. So we know our first box is X big R, X little r. Second box is X big R, X little r. Third box is X little r y, and our fourth box is also X little r y. So the question asks, what are the chances that they will have rickets in their male offspring? Well, if I look at their males right here, okay, they're both X little r y. And remember, because this is a dominant disorder, X little r means that they're normal. So 0% of their males will have rickets. But it asks, what are the chances that they will have rickets in their females? Well, if I look at their female offspring, so if I'm looking at my Punnett square, 50% of them are female, okay, because I have 2 girls and 2 boys, and both of them have an X big R. And X big R in this case means that they have rickets. So what are the chances that they will have rickets females? 50%. Okay, because they have a 50% chance of having females and both of them would have rickets. So in this case, which sex is more prone to rickets in this situation and why? Well, because this is a dominant disorder and females have 2 X chromosomes, they're twice as likely to inherit rickets. Okay, so females, because they have 2 X chromosomes. All right. So my last problem, a woman is homozygous for rickets. Remember, homozygous means that she has 2 of the same alleles. And we wrote up here, rickets is X big R. So if she's homozygous for rickets, we know that she's X big R, X big R. And it asks, what is the chance that all of her children will have rickets? Well, they didn't give us the male's genotype, but we can still figure this out. So because we know the woman is homozygous for rickets, we know she's X big R, X big R. We don't know the male's genotype, so I'm going to put X question mark Y. So if I fill this out, okay, I have X big R, X question mark, X big R, X question mark, X big R Y, and X big R Y. So remember, rickets was a dominant disorder. So if I look at this, I just need to have an X big R in order to have rickets. So what is the chance that all of her children will have rickets? Okay, it's going to be 100% because they all have X big R. Okay, and this is a dominant disorder. So I hope this helps. Hop on to Google Classroom right now and complete your quiz and let me know if you have any questions. Bye.